Hi there, hope you're doing fine. Today we will be discussing about various types of matrices, and the first type we are going to see is a row matrix. A row matrix is a type of matrix that has only one row. So the order of this matrix is 1 by 3, and we can have this type of row matrix. It has one row and two columns. As you can see, any matrix with only one row and any number of columns is called a row matrix. Now we will get to know column matrix. Any matrix with only one column and multiple rows is called a column matrix. So as you can see, this has 2 rows and 1 column. This has 3 rows and 1 column, and this has 5 rows and 1 column. So generally speaking, any number of rows with 1 column, a matrix with any number of rows with 1 column is called a column matrix. Now we will see another type of matrices. Another type of matrix is called a rectangular matrix. Any matrix with a number of rows and columns, any matrix with a different number of rows and column is called a rectangular matrix. So as long as the number of rows and columns are different, it's called a rectangular matrix. A row matrix is a type of rectangular matrix. Column matrix is also a type of matrix, but it's categorized into a very specific subcategory. It just has to say that if the number of rows and columns are not matching, it's called a rectangular matrix. Now, a square matrix is the opposite of rectangular matrix. If the number of rows and columns are the same, it's a square matrix. So order of 2 by 2, 3 by 3 are called a square matrix. Even a row with only one entry is also a square matrix because it can be classified as 1 by 1. So now we will see what's meant by a null matrix or a zero matrix. Any matrix with all the entries, all the numbers, you can say, all the entries, if they are 0, it's called a null matrix or a zero matrix. We will have to know a null or zero matrix because it's going to be used in certain operations. So that's why we'll have to understand this type of a matrix. So if all the entries of a matrix are 0, it's a null or zero matrix. Now we will understand what's meant by transpose of a matrix. Whenever we change rows into columns of a matrix, it becomes a transpose of that matrix, denoted by if let's suppose if this matrix is denoted by A, then its transpose will be written like this with the t in the exponent place. So it's an operation. As you can see, whether we can turn rows into columns or columns into rows, this operation will be called a transpose of a matrix. So let's see. I'm gonna take this row here and turn it into a column. As you can see, now I'm going to take the second row here and turn it into a column. And now I'm going to take the last row here and turn it into a column. And as you can see, this has converted a row into a transpose. This has turned a matrix into a transpose of that matrix. So hope it's understandable. Let's move on. So let's look at a few more examples. So let's take this matrix here and let me perform a transpose operation. So let's take the first row. I'm going to convert it into a column. I'm going to take the second row and convert it into a column. So this has converted a row into a transpose of itself. All right. So there is a thing here. It can not only transform the shapes of it, but it also changes its order. So if you look at this a matrix here, it's 2 by 3, 2 rows and 3 columns. And now look at here, now it has 3 rows and 2 columns. So it reverses the order of a matrix. Now let's learn what's meant by negative of a matrix. A negative of a matrix is such a matrix that if you add the original matrix and the negative of that matrix, it will become a null or zero matrix. The simple algorithm is to obtain a null matrix or zero matrix is to first take a matrix here and convert it into a, let's look at a matrix specifically here. Now, what should we add here that will convert this matrix into a null matrix that will have all the zeros here? Now, if you remember from basic addition here, let's suppose I have a number. What should I add with 7 that will make it a 0? Well, I know everyone is smart enough. If I add a -7 here, it will convert it into a 0. So now we will add strategically some values that will allow us to add those two matrices together. I know I haven't talked about matrix addition here, but it's very easy, so we can do it fairly quickly. We can only if we are adding two matrices with equal order, right now it's 3 by 3, we should only add the corresponding entries here. What do I mean by corresponding entries? Let's suppose it has only one -1 here, so it will add with this one here. Similarly, the -3 here will add with 3 here. So let's draw another operation matrix here. So 1 will add with -1 here. The next entry 3 is always in its place. Now I will add with -3 there, and we will add 1 here to make it a 0, -2 here, -4 there, -6 there, 7 there, -5 there, and -9 there. So as you can see, we will add these specific numbers or the negative them that will make it a 0 in each corresponding entry. Now, if you add them together, each entry will become a 0. So that's what meant by a negative of a matrix. If this matrix is denoted by A, this negative of a matrix will be denoted by A minus. So that's what it means by negative of a matrix. Now let's discuss a symmetric matrix. What is a symmetric matrix? A symmetric matrix is always a square. A square matrix, if you transpose it, it will revert back to its original self. What do I mean by that? Last time we saw, if we take a transpose of a matrix, it transforms it into a different type of matrix. It order reverses, the columns become rows, rows becomes columns, but there is a type of matrices, if you perform a transpose on it, it will not change its shape or the place of its entries. So right now we have this matrix, let's call it A. Right now I'm performing a transpose on it, so let's convert its rows into column. I'm going to take this here, 1, 2, 3. I converted the row into a column. Let's take the second row here. It's 2, -1, and 4 here. All right. Now let's take the third row here. It will be 3, 4, and 0. And as you can see, despite taking a transpose on this matrix here, it does not change it in any way. Neither it changed the sign of the numbers, nor it changed the place of the entries there. So if I'm a square matrix, if you perform transpose on it and it spits out the exact matrix, that matrix can be called a symmetric matrix. So it is immune under a transpose operation. Now let's talk about the specific type of matrix here, which is called a skew-symmetric matrix. A skew-symmetric matrix, which is also a square matrix, is a type of matrix. If you take its transpose, it becomes the negative of that matrix. So let's look at an example here. Let's call it A, and its values are 0, 2, 3, -2, 0, 1, -3, -1, and 0. Now let's take its transpose here, and let's see. I'm going to convert the first row there into a column 0, 2, and 3 there. Now let's take the other row there. I'm going to convert this into a column there. Now take the last row and convert it into a column. And as you can see, its sign there, polarity sign there, is in opposite to the original here, which is, if you add them together, now it's the negative of the original. So if a certain matrix, if you perform a transpose operation on it and it becomes the negative of the original matrix, that type of matrix is called a skew-symmetric matrix. All right, so let's look at diagonal matrix. This type of matrix has two types of entries there right now. So this diagonal here, from top to bottom, from left to right, down there. If this diagonal has one or more non-zero entries, and the rest of entries, which are called non-diagonal entries because they are not on the diagonal, are 0, it's called a diagonal matrix. Let me repeat that. If the diagonal has all the entries which are non-zeros, all or one or more, you can say, then it's called a diagonal matrix. So here you can see the diagonal has a 0, but the rest of the entries are not 0. You can still call this a diagonal matrix. And right here, the diagonal has 2 values, and the rest of non-diagonal entries are 0. So these all are the examples of a diagonal matrix. Now we will discuss about identity matrix. An identity matrix is a diagonal matrix, but with certain condition. First off, it has to be a square matrix. Second is that all of its diagonal entries must be 1, and non-diagonal entries must be equal to 0. So if these certain conditions are met, that type of matrix is called a identity matrix. So we will use this identity matrix in the upcoming operations on the matrices. So that's why we are learning here. This is 3 by 3 identity matrix, and this is 2 by 2 identity matrix. The last one matrix that we will be discussing is a scalar matrix. A scalar matrix is a type of matrix that has all the non-diagonal entries equal to 0, but its diagonal, all of its diagonal entries are one real number. So here all the entries are 3, so it's called a scalar matrix. If you are looking at this and thinking of, I think we just seen this as an identity matrix, you would be right, because you can pull out the 3 from this here, and it will become an identity matrix here. So I can, any matrix with an exact same number in the diagonal is a scalar matrix. So this is basically an identity matrix. I haven't talked about the multiplication here, but every scalar multiplication with a matrix is basically multiplying with each entry in that matrix. So if you can multiply it, you can pull it out. And here you can pull out the 3 here, and this will become an identity matrix here. So this type of matrix is a scalar matrix, and you can generalize it to any number. Hope this was helpful.